Concentration simply tells us how much of a substance is present in a given amount of solution. There are several ways to express concentration, such as mass percent, molality, and parts per billion, or ppm, but the most commonly used in chemistry is molarity. Let's take a closer look at the concentration of a solution and specifically how we measure it in chemistry. A solution is a homogeneous mixture composed of two or more substances. The substance present in the largest amount is called the solvent, and the substances that dissolve in it are called the solutes. There could be multiple number of solutes present in a solution, but there is only one solvent present in the solution. For example, in salt water, water is the solvent and salt is the solute. Concentration tells us how much solute is present in a given amount of solvent or solution. There are different ways to express concentration, but the most widely used method in chemistry is molarity. Molarity has a unit capital M, and it is defined as the number of moles of solute per liter of solution. Notice that it is important to measure the total volume of the solution, not just the solvent. When we dissolve a solute, the final volume may change. So we always measure the total volume after the solution is prepared. This illustration shows how to prepare a 1.00 molar sodium chloride solution. To do this, we start with 1.00 mole of NaCl, which has a mass of 58.44 grams. We place that into a volumetric flask, add some water to dissolve it, and then carefully add more water until the total solution volume reaches exactly 1 liter. At that point, we have a 1.00 molar NaCl solution. Molarity is extremely useful because it directly links the measurable volume of solution to the number of solute particles, something that's critical when performing stoichiometric calculations in reactions. For example, if we know the molarity of a solution, we can easily determine how many moles of solute are present in any given volume. Now that we've defined molarity, let's practice with some example problems to see how it's applied in calculations. Question 1 asks us to calculate the molarity of a solution made by dissolving 23.40 grams of sodium sulfate in enough water to make 125.0 milliliters of solution. Step 1 is to convert the mass of sodium sulfate into moles. Since the molar mass of sodium sulfate is 142.04 grams per mole, 23.40 grams multiplied by a conversion factor 1 mole over 142.04 grams, or alternatively divided by 142.04 grams per mole gives us 0.1647 moles of sodium sulfate. Next, we need the volume of the solution in liters. Because molarity is moles per liter, we convert 125.0 milliliters into liters. Multiplying by a conversion factor 1 liter over 1000 milliliters, we get 0.1250 liters. Finally, molarity is simply moles divided by liters. So, the concentration of this sodium sulfate solution is 1.318 molar. Now, let's look at question 2. This time, we are calculating the molarity of a glucose solution. We dissolve 5.00 grams of glucose in enough water to form 100.0 milliliters of solution. Pause the video and follow the same steps that were used in question 1. Again, The first step is to convert grams to moles. The molar mass of glucose is 180.0 grams per mole. Multiplying by a conversion factor, 1 mole over 180.0 grams gives us 0.0278 moles of glucose. Next, convert the volume by multiplying by a conversion factor 1 liter over 1000 milliliters. This gives us 0.1000 liters. Now, we calculate molarity 0.0278 moles over 0.1000 liters. So, the molarity of this glucose solution is 0.278 molar. Now, let's try an online activity to reinforce our understanding of concentration. Log into the course site on D12. Click the Content tab at the top. In the left menu, open Lecture Material, then select the module titled 04 Concentration. Under that module, find Lab 04 Concentration and download the worksheet. Complete the worksheet as you work through the online simulation. Return to D12 and under the same module, open Simulation - Concentration and Beer's Law. In the simulation, select the concentration window. Drag the concentration meter into the solvent water. Make sure the meter remains immersed in the solution at all times. Initially, the meter should read 0 because no solute has been added. From the solute list at the top right, choose copper 2 sulfate and ensure solid is selected. Add the solid CuSO4 to the water using the sample shaker. Watch the concentration meter and observe how the concentration changes as the solute dissolves. Click the Water tab at the top right to add solvent. Observe how the concentration meter changes as you dilute the solution. Open the drain valve at the bottom right to remove some of the solution and observe the effect on concentration. Use the evaporation control at the bottom left to remove only solvent by evaporating some water. Does evaporation increase or decrease the concentration of the solution? When you have finished exploring, open the downloaded worksheet, follow the step-by-step instructions, and fill in the blanks.